Hello there guys, welcome back to another epic inexorable maths video. We're going to derive the sine rule today for trigonometry. So the sine rule, very popular, famous formula used in GCSE maths, A-level maths, and any other sort of exam system that you can think of. It's a really important formula for geometry and trigonometry. What does it say? It says if you have any triangle, even if it's not a right angle triangle, if you do this setup, how I've drawn here, so each angle is a capital letter, and the lowercase version of that capital letter is the side length opposite the angle. So for example, angle here, this is angle capital A, which means that the length, lowercase a, is opposite that in the triangle. And this happens with B and C as well. The sine rule says that sine of the angle A divided by the length lowercase a is the same as sine of the angle B over lowercase b, which is the same as, my head's probably in the way right now, but sine C over lowercase c. Let me just move the camera. My webcam could be in the way there. So this is the equation, this is the formula for the sine rule. This is very useful, very useful. We can do example questions in the future, but this is just the derivation. So that's that formula. Now, where does it come from? That's what we're going to do in this video. So let's get straight into the derivation. Okay, so what we're going to do is we're going to do a vertical line here, dotted in. I'm going to call this line h. It's got a length of h. And I've drawn it in a way that it's perpendicular, to the length b, which means that these two are right angles. Why have I done that? Well, I want to create right angle triangles. You can always create, even if the triangle is not right angled, by drawing a line, you can always make it be right angled. So I've basically made it be right angled by doing this, or I've split it into two right angle triangles. The reason I've done this is so that I can use normal SOHCAHTOA trigonometry on this. So what I'm going to do is I'm going to use sine of the angle A, which is this angle here, and using normal SOHCAHTOA, well, sine is opposite over hypotenuse. The opposite in this question is actually h, so that might be a bit confusing, but the opposite side length is h, isn't it? And the hypotenuse is c, so it's h over c. So hold that thought for just a second. That's the triangle on the left. The triangle on the right, though, is also going to tell us something. So using the triangle on the right, we can also say that sine c, this is this angle here, this is going to be equal to what? Well, it's just opposite over hypotenuse again. So it's h over a. Okay, cool. Now, if we make h in both of these equations the subject, we can say that h is equal to c multiplied by sine a, and h is equal to a multiplied by sine c, isn't it? Now, because they're both equal to h, they must be equal to each other, which means that c, that's a lowercase c, times sine capital A must be equal to lowercase a times sine capital C, like that. Then, by just doing some simple rearranging, you can divide both sides by a, and then divide both sides by c. And I'll do that in two steps. So dividing by a, we get sine a over a times c is equal to sine c. And then finally, dividing by c, we get sine a over lowercase a is just equal to sine c over lowercase c. Now, in order to get the equivalence for a, b, and c, you just need to do this 3 times. So you do it with a and c, you then do it with a and b, and finally you do it with b and c. But you can do it with all 3, and then you can show that they're all equal to each other. If a and c are equal, and c and b are equal, then a and b must be equal, they all must be equal, so you just get that equivalence. But this is the gist of it, really. And really, in almost any case, really what people use the sine rule for is you don't normally use all 3 angles, all 3 sides, you normally just use 2. And because it doesn't really, I mean, you know, I could have labelled this in any way that I wanted. I could have labelled the side C as B, and then we'd have sine A over A equals sine B over B. But this is the gist of it. This is the important part of the derivation of the sine rule. I'll leave the rest to you if you want to go and do the other two. But really, it's just the same thing again. So guys, thank you so much for watching. I highly appreciate it. I hope that that was useful for you, and I will see you in the next video. Cheers.